Hey, hi, hello everyone. In this question, we are going to solve same count factors. So we have solved already, but this time we are going to solve in very optimal manner. Okay, actually this is not optimal solution. This is a brute force solution. Brute force solution means whatever the idea comes in our mind initially, we are going to solve in that manner. But now we are going to solve in an advanced manner, which means optimal solution. Okay, your next question is, so why do we solve it in optimal manner? This answer also will give the input. Then optimal solution also will give the input. Then why do we solve? Why do we approach optimal? Right? See, why do we approach optimal means, so I'll explain. So please be listen next 5 minutes. Our online judges na, so in every online judges, it's just an assumption. Okay, so it's approximately some assumption. So in every online judges will take, it is a 1 gigahertz, which means 10 power 8 iteration, 10 power 8 iteration in 1 second. Okay, then what will time it will take for one iteration? 10 power 8 iteration in 1 second. Then one iteration means one iteration, how many second? 1 by 10 power 8 second, right? See, in this question, what is the iteration actually? If your input is 20, it will take 20 iteration, right? If your input is 50, it will run from 1 to 50. So it will take 50 iteration. So for the small number, it is fine. So let's take a big number. My n is right now 10 power 8. How many time it will take? 1 second. Because our online compiler 10 power iteration in 1 second. So I increment my n is a 10 power 9 right now. I'm just incremented by 1 values. Okay, 10 power 9. Then how many times it will take? So let's take 1 iteration is a 1 power 8 second. What will 10 power 9 iteration? 10 power 9 into 1 into 10 by 18, right? So 10 power 9 into 1 divided by 10 power 18. So how many? 10 power 1. So 10 seconds. So just because I am adding one iteration extra, 10 power 8 to 10 power 9, it will take a 10 second. So now your n is a very huge number, 10 power 18. It's a very big number. Okay, but this is the possibility. N is a 10 power 18. Then how much time it will take right now? See, 10 power 18 into 1 divided by 10 power 8. So 10 power 18 into 1 iteration. Actually here we have a 10 power 18 iteration. 1 iteration will take 1 by 10 power 8 seconds. Then how much time it will approximately? 10 power 10. 10 power 10 seconds. Guys, listen carefully. How much time it will take in years? 10 power 10 second means how much time it will take in years? Approximately, and Google it and say me. It's approximately 317 years. 317 years. Would you think you will alive? Let's imagine you are write a code. This is your code, and you are given input as a n is a 10 power 18, that much long. Would you think you will alive 317 years? Not really, right? We are not. So we are not a Nityananda. So according to Nityananda's statement, he will alive 3rd and 4th generation up to. But we are just a normal human being, so we can't alive that much time. Then what we have to do, right? So do you imagine? So now why optimal solution is very, very important? It's very, very important because we can't alive 317 years. Then what we have to do? So we have to optimize this solution. How can we optimize? So with the help of power of observation. Okay, what is the observation in this question? Okay, let's see. Okay, let me pick the number as a 24. So if I take a 24, what is the first number is a factor of 24? So we know that 1. And guys, I would like to ask one simple question. Why we are saying 1 is a factor? Because 1 divides 24 completely, right? So 24 divided by 1, remainder is a 0. We know that. If remainder is 0, what is the quotient? In this case, quotient is a 24. And just imagine, is it 24 is a factor? Yes, absolutely. So 24 also your factor. So then what is the second number is a factor of 24? 2. If 2 is your factor, so why we are saying this 2 is a factor? Because 2 is divides completely, the remainder is 0. If remainder is 0, what is the quotient in this case? 12 is your question. So do you think 12 is a factor? Yes, absolutely. So 12 is a factor. Let's take a 3, then 24 divided by 3, it's equal to 8. So 8 is a factor. If let's take a 4, 4 is a factor first? Yes, 4 is a factor. So if 4 is a factor, 24 divided by 4 equal to 6. So 6 also my factor, right? So let's continue. After that 4, 5 is a factor? No, 5 is not a factor of 24. Then 6? Yes, 6 is a factor. So if 6 is a factor, let's take 24 divided by 6, 4. So 4 also my factor. Let's take 8. Next factor is 8, right? So if 8 is a factor, also 3 is a factor. So indirectly, guys, leave it as it is. Let's take this is I and this is j. Or let's take this pair 3 and 8. 3 is I and j is 8. So if I and j is a factor, if I and j is a factor, let's take I into j equal to n, right? How many of them agree with this point? So I into j equal to n. What is I here? I is a factor of n. And if I is a factor of n, what is this j? J also factor. J also factor. Then how can we find out this j? J is nothing but, according to this expression, how can we find out this j? J is left hand side and n by I. And j is your nothing but it is n by I. So see, this is your I, this is your n by I, right? So let's continue. If you take 12, 12 is a I, 12 is a factor, also n by I, then 2 is also your factor. So if you take 24, I is your 24, then n by I, 1 is also your factor. So do you observe something? Absolutely you can observe. What is that observation? Your observation is, so my one more question is, do you want to really go to check till 24 to get the factor of 24? No. So we can check up to this number, right? Okay, so let me pick another number. Let's take an 100. This time 100 here. So this is 100. So my I is I and n by I. So let's take 1, then 100. Let's take 2, 50. Let's take 4 and 25. Let's take after that 5 and 20. Let's take 10. Here 10. So let's take after the 10. So let's take 20 and 5 is a factor. So let's take 25. 25 is a factor of 100. Then 4 also my factor of 100. So let's take 50. Then 2. So let's take 100. It's 1, right? So do you observe something here? So first just check the observation here. What is your observation? So we no need to go and check up to till 24 to get the factors of 24. We can go and check up to 4. That is enough. Why? Because I and n by also. If you find I and you know that n by I also your factor. This is nothing but it is a buy one and get one free. Buy one and get one, that concept. If you find 1, then n by I also your factor. If you found I, then n by I, 8 also your factor. So this time we can increment our count as a count plus equal to 2, count plus equal to 2, count plus equal to 2, count plus equal to 2. See, let's coming to 100. Here also count plus equal to 2, count plus equal to 2, count plus equal to 2. I am incrementing my count as a 2. Okay, so count plus equal to 2. Here what I have to do? Let's see, if my I is 5 and n by I is 20, both the numbers are different. Okay, that time I am incrementing my count as a 2. But let's see here, my count also, my I also 10 and n by I, that is also 10. This time what I have to do? Do you have to count the same number at the twice? No, we have to count in different manner. So 10, if you count this 10 once, then you no need to count again this 10, right? So this time my count equal to 1. Why? Because my I and n by e equal to equal. See, my I equal to n by I. For this case, I have to increment my count equal to 1. Okay, so what is the condition here? So we have to do condition now, we have to check the condition. So what is the condition for your observation? See, 1 less than or equal to 24, 2 less than or equal to 12, 3 less than or equal to 8, 4 less than or equal to 6. But from this point itself, 6 greater than 4, 8 greater than 3, 12 greater than 2, 24 greater than 1. Same like here also, 1 less than or equal to 100, 2 less than or equal to 50, 4 less than or equal to 25, 5 less than or equal to 20, 10 less than or equal to 10, right? From this point onwards, it will start greater than. So greater than, greater than, greater than, greater than. So according to our observation, I less than or equal to n by I. How many of them agree with this condition? So if this is true, okay, if this is true, I into I, according to this expression I am evolving, I into I less than or equal to n. This is also true. So this is our condition. So we have to increment our count. Okay, without delay, let's get into the implementation video. Then you will get some idea. See, I am getting n from user. What I have to check? Initially my count is 0 initially. Then I am going to check for int I equal to 1, I less than or equal to n. Is this? No. According to my expression, I into I less than or equal to n. We can check up to root, right? So I less than or I into I less than or equal to n, then I plus plus. Then what if I is a factor? What is n by I also factor? But in one exceptional case. What is that case? Actually, if let's take an 100, let's take 10 is your factor. This is your I. If 10 is your factor, you have to check n by I is equal. What is n by I? This time 10. So 10 equal to 10. So this time you have to increment your count equal to 1, right? So how can we check? Just I into I equal to n. Okay, so if your I equal to 10, 10 into 10 equal to 100. For this case, you have to increment your count as a 1. So I am checking first. Initially, I am going to check, is there any factor? If n mod I equal to 0. If I is a factor, I am going to check if I into I equal to n, that time I am going to increment my count equal to count plus equal to 1. Suppose else, that time I am going to increment my count equal to 2. That's it. Finally print a count. System.out.println of my count. So let's run the code. System.out.println, T is missing, always T is missing. Okay, let's give 100. If we get a 9 is a factor, then yes, for 100 we have a 9 factors. So let's run 20 we have a 6 factors. Let's check 20. Yes, we'll get a 6. And guys, let's come to the power of observation once again. See, from this case, you no need to check up to till n, right? You can check up to root. What is this point? This point is a root of n. So if your n is a 24, let's take your n is a 24. What is a root of 24? It will become 4 point something. So approximately you can take 4. So if your n is 100, what is the root of 100? 10. So you can go and check up to 10, right? So that I am saying, see, let's take your I equal to I less than or equal to n by I. So this is also true. Then I into I less than or equal to n. Both are same. Okay. And one more thing. Now see your iteration. Actually, in previous case, what is the iteration? So our n equal to 10 power 18. It will take approximately 317 years. Okay, so now my n equal to 10 power 18. Okay, but now this time I am going to take root na, so up to root operation. So 10 power 18 into root means 1 by 2. So 2 to cancel. So 10 power 9 iteration. So what will become the time of 10 power 9? See here, if your n is 10 power 9, how many times it will take? It is 10 seconds. So 10 seconds. See, 317 years to 10 seconds. This is the power of observation, guys. Power of observation. Power of observation. So that we have to optimize our code. So I hope you enjoyed this class, and I hope you have learned a lot of new things. So I'll catch up you in next interesting class. Bye bye, guys.